The broadcast is now starting. All attendees are in listen-only mode.
Welcome everybody to this webinar by the IChemE Safety Centre. I hope that everybody can hear me quite well. If not, then please just type your information or questions in the questions box or the chat box. As you could see, or many of you who have been here last time, this is a series of webinar run by the IChemE Safety Centre. And the aim with this webinar is to present the safety lore, which is the lessons learned bulletin or lessons learned publication by the IChemE Safety Centre. We publish this document, which is a 2-page publication, every 3 months, and it covers different topics. So I will be covering today key lessons from incidents during maintenance on atmospheric storage tanks. The first safety law addressed incidents on startup activities. And you can find the YouTube channel of the IChemE Safety Centre, and you can find the video uploaded to that channel, as well as uploaded to our website. I will give you the information later on. This is a series of webinars that actually we would like to run in order to let you know about our publications that are freely available on our website, and also to highlight some of the aspects that what we can learn from different accidents that occurred in the past. Now, I know that these topics are really massive, huge, and wide areas of interest, but I'd like to highlight the most important key learning points in order to give you an overview what you can think about when you want to learn from such incidents. So you will find 9 of these safety laws that we have already published, and the next one will be covering alarm management. All different topics such as flare systems, creeping changes, aging of assets, flanges, transportation accidents. So you can learn a lot from these. I would like to highlight that, first of all, I don't want to share what is the location of the accident, because that is not the remit of this publication. So that we don't want to expose those companies that suffered from these incidents, because the important part is to share the knowledge and share the lessons from what we can learn from this accident. The other aspect is, as you all know, investigation reports are really big documents, and they cover and address a lot of recommendations when you read all these investigation reports, which can be like from 50 pages up to like 200 or 300 pages length. But I would like to highlight those lessons that are associated with this particular topic. Now, my name is Dr. Susanna Jenes, and I'm the deputy to the director of the IChemE Safety Centre, and I also sit in the editorial panel of the Loss Prevention Bulletin. That is the publication of the Institution of Chemical Engineers. And we actually publish a lot of lessons learned from past accidents in that journal. And you can also write your articles, and we would like to welcome all of your ideas and learning experiences from your past. Now, atmospheric storage tanks. Everybody has idea what atmospheric storage tanks are, and in fact we have quite an extensive literature that you can find all different information about atmospheric storage tanks. What I would like to tell you now is that atmospheric storage tanks are used in a great variety of industries, and the maintenance of those atmospheric storage tanks are quite challenging, or can be really challenging. One of the most common hazardous materials held in these atmospheric storage tanks are flammable liquids. Atmospheric storage tanks are used for the storage of liquids at ambient temperature and for the storage of refrigerated liquids. Housekeeping activities, for instance, repairing, painting, cleaning, welding, grinding, and cutting are hazardous actions associated with these tanks. Major hazards with maintenance of atmospheric storage tanks are related to confined space, flammable or explosive atmosphere. It is therefore important to address these hazards to prevent incidents occurring during maintenance work. As you can see in our safety lore, usually 2 case studies are addressed and described, and these are short description of the cases with highlighting some of key learning points. And then the second page of the safety lore that tackles and provides tips and recommendations for managers, process safety engineers, supervisors, and operators, so that what they can do about to avoid that such accidents occur in the future again. Now, some of you asked that I should put some pictures in the webinar material, so here you are. In fact, the safety law document doesn't contain any pictures because you can find all these pictures on the internet from different sources of information. Now, the 2 cases. The first one occurred at a wholesale and retail facility. An explosion occurred in 2001. 2 contract workers were carrying out maintenance operations inside a 5,000 cubic meter atmospheric storage tank. The closed floating roof tank usually contained premium grade gasoline, but it was emptied for the maintenance job. The event occurred during cleaning operations, and the activity performed by employees of an external company consisted in removing residue from the tank bottom by means of scrapping. And we don't know exactly, but the most plausible theory is that spark was created by one of the workers' tools, and it is possible that it may have been boot soles points, metallic scraper, steel snap hook. Within an explosive atmosphere, this could have caused the explosion. The 2 workers were seriously injured in the incident. The tank afterwards, as you can see on the picture, was not repairable, and the operation of the storage facility was interrupted for approximately 2 months. So quite a significant time that you run, you can't run your plant. Now let's come to the points. What are the key learning points from this case? The distance of the floating roof from the tank bottom at the time of the accident was approximately 1.2 meter. The working space, therefore, in this situation was quite limited, as you can imagine. The empty tank that exploded normally contained premium grade gasoline. Now, the gasoline vapors were still in the tank, caused the explosion. The tank was equipped with only 1 manhole. That was another aspect. And what happened apparently when the incident occurred, not all the vents were open. It is likely that the atmosphere was not homogeneous, and the explosive pockets of vapor and air also existed within the tank. In addition to that, the ventilation system set up to evacuate gasoline vapors was shut down for the cleaning operations to take place. So these are the initiating key learning points. But what else? What else happened? What is also not always recognized is that gasoline collects in welds, pontoons, or floating roofs, particularly if they are not well maintained. Small pits, crevices on the surface of the steel, within the residues on the tank floor. Now, this means that there is a continual production of vapors even after the tank has been emptied. which means that explosive atmosphere measurements need to be regularly repeated, as well as constant ventilation. Now, this is an aspect that I will be covering in one of the later safety laws that I published. And so you will see also very some similar cases that actually you can find some key learning points that are quite similar to these cases, but that is normal because you can find more similarities in different incidents, but depends on the aspect that you try to address in that particular analysis. And what also happened was the limited space of movement of the workers was also an adverse factor in their escape. This will be addressed also in shift handover and permit to work safety law in the future. So briefly, this is what happened in the first case, and now let's see what happened in the second case. And we also already have some questions and comments, which I really appreciate. So thank you so much. And it is really useful. So I would like to read it now, because normally I don't, but this is really interesting that we have received. So also important is to use spark resistant tools and only allow the entry only while the lower explosion limit meter shows 0. When the intent is itself to enter the tank to remove residual material, it should be done under very close and strict supervision. These days, robots are available for executing such jobs. Really interesting and really useful comment. Thank you so much. And in the end, when I will present all the What Can I Do session, I will try to gather some more recommendations as well, and not only related to these two cases, but in general from the different sources of information. Let me just give you an example here. So for instance, the Energy Institute published really interesting guidance documents on cleaning operations and atmospheric storage tank maintenance activities. The UK Health and Safety Executive published many guidance documents that are really valuable. The US Chemical Safety Board, they have published safety bulletins that address these really similar aspects, and many loads of information are there. And thank you again for the excuse me. Thank you again for the very useful comment. Right. Let's come to the second case that occurred in an oil refinery now. A massive explosion destroyed a large storage tank containing a mixture of sulfuric acid and flammable hydrocarbons at an oil refinery. One contract worker was killed, unfortunately. 8 others were injured, and sulfuric acid from collapsed and damaged tanks polluted the local river. The explosion occurred during welding operations to repair a catwalk above the sulfuric acid tank when flammable hydrocarbon vapor was ignited by welding sparks. This resulted in a powerful explosion inside the tank. And this is also very similar to many other hot work related incidents. And in fact, I just mentioned the US Chemical Safety Board publications and incident investigations, which are really useful. And you can see all the videos that they published on the cases so that you can have a better understanding what happened. And they released a publication, and in fact I think it was not only one publication but more than one, about hot work activities and contract workers related cases. Yes, we have more questions, but I try to address them in the end. Yes, indeed, this is what I just mentioned, that the CSB had published. I will read all of these really useful comments in the end, because I believe that we can learn from each other. So I highly encourage you during this webinar that you can add your comments in the chat box or the question box, because this is all really important. Now, come back to the second case. Excuse me. What are the key learning points? So, on the day of the accident, flammable gas testing was performed only at the start of the hot work activity, but monitoring was not conducted for the duration of the repair activities. It is also important to mention as to where the explosive atmosphere measurements were made. Through the 5 hours between the last gas test and the explosion, the ambient temperature raised significantly. I think it was during summer. Now, this warming caused the hydrocarbons inside the tank to vaporize. The resulting flammable vapor leaked out from corrosion holes in the tank into the work area. The company had a hot work program in place that included written permits, but the program was inadequate. Hot work was allowed near tanks that contained flammable materials without continuous atmospheric monitoring, and the control of welding sparks was not required. You might think now that, yes, but we have sophisticated methods now to avoid such cases to occur. But I have to remind you that even very recently, similar accidents still occurred. And this is why it is important to keep repeating these key learning points, because one day, hopefully, these will be implemented. And these learning points will be, in fact, learned. Now, one of the aspects of the safety law, and this is a key part of the safety law, is to understand what you can do about such cases and such situation at your facility based on your role. And here you can see the Safety Center framework. The framework is across 6 key functional elements, which is vital according to the IChemE Safety Centre, and the members of the IChemE Safety Centre is vital to achieve good process safety outcomes. The framework is not a safety management system. It doesn't seek to replace any safety management system, but it addresses 6 key areas, which are around one specific and really important aspect, which is leadership. So those are the elements which are the systems and procedures, engineering and design, assurance, knowledge and competence, human factors, and culture. What you can see here, these are colored dots, and in our PDF version of the safety law on our website, you can see the What Can I Do session around these dots, which means that all tips and recommendations are associated with these elements. So you can get a better idea which topic and which tip actually covers which element of the framework. Let's see, what do I mean by that? What can I do as a manager to avoid such cases to occur during maintenance of atmospheric storage tanks? Safety management system with written procedures should be in place to address maintenance activities along with normal operations. Assurance activities are required to get feedback on the safety management system. What next? Routine permit to work audit program should be in place with reports, analysis, and compliance key performance indicators. Arguably, field auditing should be increased for specific and large tasks, such as tank maintenance. Contractor selection criteria and competence assurance programs, which should be in place. Now, this is a really, really important one, because let me explain. The IChemE Safety Centre has published different guidance documents that are practical guidance documents, short and straight to the point, and they can be implemented very quickly with a gap analysis within your operation. And one of them addresses competency, knowledge and competence. One of the competencies within any organizations is the recruitment process, the recruitment and selection criteria of contract workers and supply. And this is really important that at least a basic understanding of process safety is required from the recruitment team. I would like just to highlight this, that it is covered by our freely available publication from our website. Coming back to what can I do as a manager, and sorry about this extra information, but I would like to give you as much as possible. Identify the hazards and check that safeguards are available and those safeguards are adequate. Make sure that maintenance activities are considered in sufficient detail during hazard analysis reviews. Make sure that you train all personnel and include contract workers on maintenance procedures and proper use of flammable gas detectors. This is one aspect that actually is covered in many publications and learning documents, that please train your contract workers as much as possible, because they have to know all the circumstances, what are the hazards that are around their activities. Not only have a knowledge about that particular unit, but all the circumstances and the hazardous area around as well. Make sure that maintenance supervisors have the competency to undertake responsibilities and to perform their activities to a recognized standard on a sustained basis. Again, as I mentioned earlier, competency. Competency is really important. We also published a supplementary guidance document about how to reach different competency level, and it is also available on our website. Coming back to this publication, what can I do as a process safety engineer and or a supervisor? When issuing a permit, make sure that all hazards specific to the task are identified and that methods of hazard control are in place. Also make sure that operators learn about the hazards and the control measures. And I would like to highlight again that a later safety law will address permit to work cases and learning points from permit to work systems. In addition to the permit, job-specific task risk assessment is needed for higher risk activities. Any deviations from these systems must be risk assessed prior to execution. Supervise and control the work. Check that the procedures are always followed. Talk through the repair procedure with the workforce before issuing a permit to work. This is a key aspect. Communication, talk through, ask questions, and get feedback whether operators understood correctly what is going to happen, what are the hazards, what are the safeguards, and what they can and what they cannot do related to that particular activity. And please stay there and supervise their work. Process isolation and preparation plan should be clearly documented. Make sure that maintenance work is planned and integrated properly with other work to be done. What else you can do as a process engineer and supervisor? As I have demonstrated in one of the case studies, the atmosphere can change rapidly. Continuous gas monitoring needs to be conducted immediately prior to and during hot work activities, and this is to ensure that workers are constantly aware of the potential development of an explosive atmosphere. Ensure also that continuous ventilation is in place. Emergency response plan. Prepare an emergency response plan to enable workers to escape or act upon in case of emergency. Check that all personal protection equipment, which required for the work is present and fit for purpose. Ensure permit to work is handed back on completion of the job. It must be done person to person. It's not adequate that you just leave the document on the table, on the desk, on wherever, and maybe the next shift will pick it up. Feedback, follow-up is really, really crucial. Be aware that water washing may remove liquid from the tank, but not all the vapors or sludge and scale. This is what was the aspect for process safety engineers and supervisor. As I mentioned earlier, you may find much more than this, tips and recommendations. I'm not saying that there are not more to tackle, but these are just ideas where you can learn some of the points in association with such activities of maintenance. We have a list for operators, so that's what they can do specifically in their job. Let's see these. And when I mentioned these are the learning points for management, these are the key learning points, and what can I do, recommendations for process engineers and supervisors, and these are for the operators, I mean, they can actually, and they are highly recommended to read all the aspects, not only those that are related to their activities, because it is better to see the complete picture. However, with this document, with this publication, I wanted to highlight that specific areas that operators have to have responsibility, take responsibility, have the ownership, and those are specific for them. However, they should also be aware of some of the aspects that are related to the management and the supervisors. So it is a cross-learning, basically. As an operator, make sure that no flammable gas or vapor is left inside the tank prior to hot work activities. Properly test for explosivity, performing gas monitoring before and during hot work. Check that you have a fire watch and a fire extinguishing equipment present. And also ensure that relevant personal protection equipment is available, such as breathing apparatus. Gasoline, as I mentioned earlier, collects in welds, pontoons, small pits, crevices on the surface of the steel, and within residues on the tank floor. So regularly repeat explosive atmosphere measurements as residue or corrosion is disturbed. Vessels should be not only isolated and emptied, but also safely ventilated to remove flammable vapors. Before anyone enters the tank, make sure that atmosphere is measured and assessed for explosivity and oxygen content. The air ventilation must be continuous and sufficient to ensure a safe working atmosphere at all times. I would like to highlight this is an aspect that I will be covering at the Permit to Work Safety Law. However, there is also a great variety of publications by those institutions and authorities that I already mentioned. So you can get all the information from these publications and really valuable information about how to avoid such accidents, which may seem trivial, but they are in fact need to be repeated. Make sure that the system that you work on is properly isolated and locked out, blinded, or disconnected, and electrical isolation of remote operated valves to prevent them being operated in error. Do not depend only on valve isolation because valves can leak. Cover and seal all drains, vents, manways, open flanges, and all sewers. Don't forget, on completion of the job, de-isolate all equipment, including tank vents. So these are the tips, recommendations that I wanted to hand over to you about maintenance activities of atmospheric storage tanks. And if you want to learn more, or if you are interested in the Spanish version of the safety law, please find these publications in English and Spanish on our website. And there is also a podcast where with the director of the IChemE Safety Centre, Trish Karin, we discuss the safety law, and you can download even that podcast. And please feel free to share all the information among your colleagues, clients, customers, because this is something that if you find relevant to your activities, or if you find it useful, then please do and share. I will try to answer questions. However, this is a very, very wide area of interest, and so if I'm not able to answer your questions right now, please send them by email, and I try to answer to those questions to my best knowledge. I think we have, oh yes, and where you can find us. That is really important because I always receive these emails after the webinar. Where can I find the webinar video? Where can I download it from? Now I'm telling you, we have our YouTube channel. This is it, the IChemE Safety Centre YouTube channel. I will upload the webinar after this presentation immediately. And then you can find us in different forums, more specifically Twitter, LinkedIn. We share also these links and the YouTube link on LinkedIn. We have Instagram profile and Facebook profile, but you can find us on our website. Here I show you, and please just feel free to send any questions, any comments, any recommendations that you have to our email address that you can find here, and you can reach us as well. Now I try to address the questions, and thank you so much for listening to my presentations today. So the process isolation usually is not involving the contractor. Some of you says that witnessed one accident where the isolation of the vessel is done by the company in adequate manner only by nitrogen instead of steaming. A big fire has been resulted with an injured person. Thank you for sharing this. This is really interesting, and this is really useful, I believe so. A question about, do you have any studies on concrete storage tank failure? Not as such, but I address a concrete failure as a result of aging in the aging safety law. So you can find more information on that in that particular law. What else do we have here? Oh, okay, there is a really, really long. Yes, indeed. Thank you. Thank you for the kind reminder. In fact, yes, this is the 10th anniversary of the Macondo accident. And in fact, the IChemE Safety Centre published a short video with some key learning points from that accident. You can find that also on our website and different forums. And yes, as you mentioned, one of the findings on the incident was that there were competency issues. Even in hot work, as per your experience, a lot of competency gaps exist, and a lot of risk tolerability limits rise when people take risk time and over again. It is really a cultural issue when it comes to ensuring hot work process is followed as per the intent and no deviations are allowed. Yes, indeed. Thank you so much for highlighting that. Okay. People doing the hot work are always aware that in case of any leak, there can be fire and explosion, and they also know that for them to know about gas leak, some gas detection needs to be there. Still, they take risk because they believe that people have given them the task, have taken care of other things. Really important. Thank you so much for highlighting this. This competency of people doing the job needs to be developed, as people who get hurt need to be empowered with the power of saying no, which again is to be driven by leaders. And people need to be competent about what risk they face. Indeed, really crucial. Leadership is important. Thank you. And I would like to highly thank you for your really great contribution. Oh yes, a question about any special considerations for refrigerated storage tank. I try to gather that information and let you know. In fact, Bologna University did a research on risks and potential accident scenarios related to refrigerated storage tanks. And at my previous job at the European Commission Joint Research Centre, I published also with a team of experts. We covered potential accident scenarios for refrigerated storage tank, atmospheric storage tanks, for different substances. So I am very happy to share that information. Any information on ethanol storage and safe handling and removal of hazards? There are some cases that I've come across about ethanol storage tanks, so I will make sure that I will answer to the question as much as I can. So thank you. I would like to close now this webinar. Thank you so much for attending, and hopefully I will see most of you for the next webinar, which will be covering flare systems. So thank you and goodbye.